Hey everyone, I hope you're doing well. My name is Jeremiah Farias. I'm a registered dietitian and I've been researching health and wellness for a long time. My specialty is helping those suffering from blood sugar dysregulation issues like diabetes, prediabetes, and low energy levels. Today's video is on the question of what causes type 2 diabetes. I argue it isn't carbohydrates. Instead, what I believe is at the very root of type 2 diabetes and blood sugar dysregulation is impaired cellular energy production. What does that mean and what can we do about it? In this video, we will discuss some of the things that impair cellular energy production and how we can begin resolving this issue. You've probably heard that diabetes is caused by consuming too much sugar, too many carbohydrates, which causes insulin resistance. That's not true. That's really an incomplete story. In reality, diabetes is a state where the individual is having issues metabolizing glucose or sugar in the cell and turning that into cellular energy known as ATP. But that doesn't mean the sugar or the glucose was the cause of that dysfunction in the first place. Instead, we should be asking what is impairing the cell's ability to use that glucose. If you have gone to the doctor for type 2 diabetes or any other blood sugar dysregulation issues, you'll likely recall your conventional medical doctor. They may tell you count carbohydrates, maybe limit them to a certain amount per meal. I would argue conventional medicine provides little valuable guidance on the quality of those carbohydrates and other important factors that I believe need to be considered. And I'll mention some of those today. They may also recommend medications once you've tried to implement their vague, unhelpful advice, but then find yourself in the same place as when you first came to see them, or maybe worse off than before. Alternatively, in functional medicine, you may be told to simply avoid carbohydrates altogether, but this doesn't get to the root of the issue. It just takes away the challenge of the carbohydrates. So people may actually experience or see on lab values fasting blood sugar, fasting A1C decrease as a result of restricting carbohydrates. But once they add the carbohydrates back in, they find themselves where they started or where they were before. And their other symptoms and issues associated with blood sugar dysregulation may still be present. They don't feel better. They just saw an improvement in the numbers. Quite possible. A great example of this, there's a nutrition researcher named Kyle Mamunis, and he equates taking away carbohydrates, restricting carbohydrates to improve blood sugar levels, like someone who has lactose intolerance, removing lactose-containing foods from their diet. You will see an improvement in symptoms associated with lactose intolerance, but you have not resolved the lactose intolerance. That's still there. You add back in, you're going to experience the symptoms associated with it. Same thing with the carbohydrates. We want to, again, get to the root of it. Both of these approaches, I'd argue, functional and conventional medicine, are not always asking, why is the body having this issue in the first place? So we can define insulin resistance. What is that? You may have heard that term before. I think it's helpful to review it first. Insulin is the hormone produced by the beta cells in the pancreas. They release it in response to carbohydrates. So you consume a carbohydrate-containing meal, fruits, potatoes, rice, juice, etc. The body will metabolize, digest that carbohydrate. It enters then the bloodstream in the form of glucose. The body releases insulin to help store it into the cells. The typical relationship between glucose and insulin is insulin's like a key that unlocks the cell, allowing glucose into it. So in the state of insulin resistance, we can imagine that this key, which is insulin, is no longer working on the cell. It's as if the cell has changed the locks, and so it's not allowing it in anymore. When it doesn't allow glucose into the cell, blood sugars rise, and that's why you're having high blood sugars in type 2 diabetes. So that's the the narrative that's typically understood and shared to explain the relationship between insulin and blood sugar and insulin resistance and what the issue is. However, in this video, I'm going to share some research that highlights glucose is actually able to enter the cell without insulin. And so I'm going to actually start sharing my screen now, and we can get into this. So again, what causes type 2 diabetes? I argue it's not the carbohydrates. So first and foremost, we have this concept known as non-insulin mediated glucose uptake. As its name implies, glucose uptake is occurring without the help or assistance of insulin. And in this paper, it states in the fasting state, approximately 83% of glucose uptake occurs via non-insulin mediated mechanisms. In the human body, glucose uptake is accomplished via two mechanisms: insulin mediated glucose uptake, which only occurs in insulin sensitive tissues like liver, muscle, and fat cells, adipocytes, and non-insulin mediated glucose uptake, which occurs in both the insulin sensitive and non-insulin sensitive tissues, which the non-insulin sensitive tissues are the brain, blood cells, nerves. But as you recall, this occurs in both those that are insulin sensitive and not. And in this paper, the authors mentioned, we conclude that in the post-absorptive state, so after a meal, non-insulin mediated glucose uptake is the major pathway for glucose disposal for both normal subjects, those without diabetes, and subjects with non-insulin dependent diabetes. So they don't require exogenous insulin. They don't have to inject themselves. So right here, glucose is able to enter the cell at a significant rate without insulin. Next, insulin independent glucose uptake. Very, very similar concept. And this paper highlights GLUT1 is insulin independent and widely distributed in different tissues. Thus, insulin independent glucose transport through GLUT1 can meet basal needs for the muscle cell. GLUT1 is it's called a glucose transporter. There are numerous glucose transporters. GLUT4 is one that is dependent on insulin, but GLUT1, as it says right here, is throughout the body, different tissues of the body, and very importantly, it can meet the basal needs of a muscle cell. Muscles are a huge reservoir for glucose. This is why it's important and beneficial to have enough muscle mass, which that can be a future video. And the last concept is known as glucose effectiveness. Glucose effectiveness is defined as the ability of glucose to stimulate its own uptake and to suppress its own production under basal constant insulin concentrations. Under conditions of declining insulin secretion and action, like in type 2 diabetes, the degree of glucose effectiveness assumes increasing significance in determining the level of glucose tolerance, both in fasted and postprandial states. So glucose as a molecule can impact its own, influence its own uptake into the cell. So this is, again, quite fascinating. So if glucose can enter the cell without insulin, why do those with diabetes have high blood sugar levels? This paper poses the question, is fasting high blood sugar of diabetes due to overproduction of glucose by the liver or underutilization of glucose by peripheral tissues? And this researcher, Schaefer, he hypothesized that insulin has two classes of action. It's excitatory, but also inhibitory. So for example, insulin can inhibit the process of lipolysis, which is the breakdown of fat tissue. It inhibits proteolysis, the breakdown of proteins, muscle tissue, lean tissue, glycogenolysis, gluconeogenesis, and ketogenesis. So it inhibits these things from occurring. There's a naturopathic doctor, his name is Dr. Brian Walsh, and he proposes that insulin is not an anabolic hormone that's often shared in just many circles, but instead it's anti-catabolic. It opposes, the breakdown of tissues. And And so this makes sense when you understand this. In the fasting state, virtually all glucose comes from the liver, from a combination of glycogenolysis and gluconeogenesis. When hepatic, which is liver, the liver glycogen stores are plentiful, most glucose comes from glycogenolysis. Glycogenolysis is the breakdown of the liver glycogen, stored carbohydrates, and it breaks it down, sends it into and releases into the bloodstream to maintain blood sugar levels, to nourish cells that require glucose. Then it says, but as hepatic liver glycogen stores become depleted, more comes from gluconeogenesis. And gluconeogenesis is the conversion of non-glucose, things like proteins and fats, to create glucose. So this is why those with diabetes, away from a meal, like especially fasting, you just fasted overnight, you had nothing to eat in quite a while, why someone with diabetes has chronically high fasting blood sugar levels. They're insulin resistant, and so there's nothing to stop the production or the liver from producing more and more glucose. Diabetes is a state of hyperglucagonemia. Glucagon is one of the hormones it opposes the actions of insulin, and so that's why it's high. And that could be another video kind of diving into that a bit more. So finally, let's get into this concept of impaired cellular energy production. I have a couple of quotes that I think are really helpful, and it highlights the importance of this cellular energy production, and that diabetes is a state. We're going to get to that in a little bit. But first, you have a biologist, the late Dr. Ray Peat. He says, if we learn to see problems in terms of a general disorder of energy metabolism, we can begin to solve them. And then another researcher, nutrition researcher, Dr. Chris Masterjohn, says very succinctly, energy metabolism governs everything. If you have an impairment in cellular energy production, you cannot produce energy from the foods that you're consuming, substrates like fats and carbs, you're not going to be well. You need to be able to do that in order to heal, to be a healthy individual. And this is connected with diabetes, in addition to other chronic diseases, believe it or not. So let's take a look at some research that highlights diabetes is a state of impaired cellular energy production. So right here, this paper is titled Characterization of Cellular Defects of Insulin Action in Type 2 Non-Insulin Dependent Diabetes. It says glucose oxidation as measured by indirect calorimetry has been known to be reduced in non-insulin dependent diabetics. So again, these diabetes or diabetic patients are not reliant on exogenous insulin. And then right here, this paper, this chart, it has three groups of individuals. You have lean non-diabetic subjects, obese non-diabetic subjects, and those with diabetes but not on insulin. Down here, glucose oxidation, highest in the lean non-diabetics, and then obese non-diabetics are just right below that with regards to glucose oxidation, and then lowest is those with diabetes. And so decreased glucose oxidation is due to, and then leads to decreased cellular energy production, and is a result of decreased cellular energy production. And let's look at one more example. So mitochondrial dysfunction in the elderly. And then this paper highlights our results suggest that insulin resistance in the elderly is related to increases in intramyocellular fatty acid metabolites that may be a result of an age-associated reduction in mitochondrial oxidative and phosphorylation activity. So this mitochondrial oxidative and phosphorylation activity is the, again, creation of ATP, of that cellular energy. There's a defect in this process occurring. And that intramyocellular fatty acid metabolites, that's due, again, to impaired utilization and oxidation of things like fat and glucose, meaning there's too much coming in for the cell to handle. It needs to convert it into other byproducts, and these byproducts build up. They have negative consequences within the cell. It impairs, it further stresses the cell, and a dysfunctional cell is not going to sufficiently produce energy. Okay, we're at the halfway point in this video, and I know it's a lot of information, but I wanted to quickly share this free resource that I created that provides you with practical information that will allow you to begin improving your blood sugar metabolism. You can find a link in the description below. I'll mention again towards the end. But next, let's review 4 things that impair cellular energy production that can drive and cause diabetes. So polyunsaturated fats and lipid peroxidation. So what is that? Polyunsaturated fats are a group of fats. You have 3 primary ones. You have trans fats, but we'll talk about 3 in this situation. Saturated fats, monounsaturated fats, and polyunsaturated fats. Saturated fats, they're given the name saturated because all of the carbons on the chain are saturated with hydrogens. There's no place for something like oxygen to bind. So it's very stable fat. You have monounsaturated, mono means one, so it has one double bond. So one location, a place where oxygen can bind, still relatively stable, but there's always a chance that can oxidize when exposed to things like oxygen, heat, and other extreme conditions, like reactive oxygen species. And then there's polyunsaturated fat. Poly means many, so it's more than one, so usually 2 or more double bonds, meaning this fat is easily damaged, prone to what's called oxidation, the binding of oxygen. And the issue with polyunsaturated fats, especially when they make up the cell membranes of throughout our body, and even the mitochondrial membranes. If you remember in biology, the cell has a phospholipid bilayer, and this is made up of the fats that we consume. You consume a lot of certain fats, like polyunsaturated fats. They make up the membrane. Because they're highly reactive, if you have an increase in reactive oxygen species, this can initiate the formation and damage and formation of things called lipid peroxides. And these lipid peroxides are some pretty nasty compounds, and they are associated with things like Alzheimer's, asthma, diabetes, and other cardiovascular complications. You need certain antioxidants to reduce and resolve this damage. So it increases oxidative stress. It increases the stress on the antioxidant system of the body. And so I'll just read a little bit here of this paper highlighting the byproducts of lipid peroxides. So lipid peroxidation, including its prominent byproducts such as malondialdehyde, MDA, and 4-hydroxytunonolol, or 4-HNE, has been long linked with worsened metabolic health in patients with type 2 diabetes. Lipid peroxidation, for that matter, defines an oxidative degradation of lipids, the breakdown of fats or lipids, which is a destructive feature of oxidative stress leading to damage of cellular membranes, resulting in accelerated apoptosis, which is programmed cell death. The body does it intentionally, and just cell death. Increased oxidative stress and lipid peroxidation appears to be the detrimental factor associated with insulin resistance, beta cell dysfunction. Those are the cells within the pancreas that release insulin, produce and release insulin, impaired glucose tolerance, and ultimately type 2 diabetes. And so I have a little more on the polyunsaturated fats. So polyunsaturated fats and mitochondrial proton leak. What does that even mean? So I'll read this from this paper. However, unsaturation index and omega-3 polyunsaturated fatty acids content correlated significantly with proton link per milligram phospholipid when literature data from reptiles and rats in different thyroid states were included, giving some support to the suggestion of a general role for phospholipid fatty acid composition in determining mitochondrial proton link oxygen consumption. So what does that mean? When you have the membrane of the mitochondria composed of polyunsaturated fats, be it omega-6 or omega-3s, this results in the leaking of energy of protons. And so it's an insufficient process of producing energy. Remember, we want to optimize energy production, and any impairments, anything that impairs that process from occurring is going to negatively affect how the cell works overall. And then lastly, I mentioned that 4-hydroxytunonolol, and this byproduct of lipid peroxides. It says, while 4-HNE displays targeting of many cellular components, proteins, and cell types, Mitochondria are a prominent target of its toxic activity. Since the mitochondrial electron transportation is one of the primary sources of endogenous reactive oxygen species, ROS, it is also one of the more vital cellular components susceptible to 4-HNE attacks. So this byproduct, 4-HNE, it targets and it's uniquely damaging to the mitochondria, further again, impairing cellular energy production. The next thing that can drive issues for glucose, diabetes, are micronutrient deficiencies. This figure right here, it discusses the nutrients that are required for a healthy mitochondria. You can see there's a ton of them. This is in the importance of eating a very nutrient-dense whole food diet. I'm only going to focus on one for the sake of this video, but thiamine is an essential cofactor in most organisms and is required at several stages of anabolic and catabolic intermediary metabolism, such as intracellular glucose metabolism. So you need thiamine to metabolize glucose within the cell. Without it, you can't. And so it's to highlight the importance of these micronutrients. But you'll see it's not just thiamine, a ton of other micronutrients, other B vitamins, copper, selenium, zinc, iron, are required to transform the food we consume into energy within the cell. So third, toxins. There are many toxins, unfortunately, in our environment, but a very prominent one that maybe many people hear about is bisphenol A, BPA, found in plastics, even personal care products, or our water, unfortunately. And so this paper right here, it saw there was a reduction in glucose oxidation in the gastrocnemius muscle, and an increase in circulating insulin levels contributed to the development of insulin resistance in these animals. It was done in animals. It's not ethical to expose people to a toxin to see then how it affects their physiology. So the best way to do this is, using animal models, but animal models show clearly this impacts the muscle cell, in this case, the calf muscle, to oxidize and use glucose. And then this figure from this paper, again, highlights BPA increases glucose production and reduces glycogen synthesis in the liver, with a reduction of glucose oxidation and an impairment in insulin signaling. And then last, stress, cortisol, known as glucocorticoids. So glucocorticoids, GC, they inhibit glucose utilization also by reducing both glucose uptake and glucose oxidation in skeletal muscle, and WAT is white adipose tissue. Two major tissues involved in insulin responsive glucose utilization. These glucocorticoid effects counteract those of insulin, which promote glucose uptake, glycolysis, and glucose oxidation. So this is in the setting of glucocorticoid drugs, things like prednisone for pain and inflammation that are often prescribed. It's very well known that those medications can cause diabetes and insulin resistance. Now you may wonder, I don't take these medications. Why should I worry about that? As you probably recall, cortisol is naturally produced within the body. Unfortunately, in our modern day, there's a lot of stress that we're under. And this paper highlights the effects of stress on cellular energy production, the mitochondria, the organelle mitochondria. So it says excessive, acute, or prolonged challenges, chronic stress, to the mitochondrial homeostasis can exceed mitochondrial reserves and lead to abnormally increased or decreased mitochondrial biogenesis, respiratory chain dysfunction, decreased ATP production, increased reactive oxygen generation, lipid peroxidation, mitochondrial and nuclear DNA damage, and increased cell apoptosis and or necrosis. So stress does a ton of bad things as it relates to cellular energy production. I just defined mitochondrial biogenesis involves the synthesis of new mitochondrial DNA, protein, and membrane. So anytime you have the mitochondria's ability to repair its membrane, its various proteins and DNA, is going to impact its ability to produce energy, create ATP. And then here again, you see there's increased lipid peroxidations, which we already went over, how those impact cellular energy production. And again, we want to do what we can to manage stress, to address stress. It's easier said than done, but just to highlight, you could be doing everything right, and maybe you are nutritionally, exercise, but still a lot of stress, things that we can do to help mitigate the stress. I help people, manage that and navigate that. And I'll talk again about maybe how you can work with me if that's something you're interested in. So that's it. I want to summarize, though, everything that we reviewed. Glucose can enter the cell without insulin. High glucose levels in diabetes are not from lack of uptake or clearance, but too much production via the liver, something called hypergluconemia. Type 2 diabetes and other blood sugar dysregulation is driven by impaired cellular energy production. What impairs cellular energy production? Polyunsaturated fats play a role. Nutrient deficiencies play a role. Toxins, cortisol, chronic stress that's not being managed. So as I mentioned in the middle of the video, I have a free resource that you can download. In it, you'll find information on the importance of protein, ideal protein sources, preferred carbohydrate sources. Again, carbohydrates aren't the issue. It's the type and other factors that one needs to consider. Avoiding limiting saturated fats and their sources, the importance of that, where are they found, and other things that they can do within the body, and some more information. There's 5 steps, at least in this guide. And you'll find that a link to that guide, to download that guide, in the description below. And if you're needing more support in improving your blood sugar, I also offer a free 30-minute discovery call to learn about your health goals and share how I can help. You can find a link again for that discovery call in the description. Also, I'm currently credentialed with a couple of insurance companies, so I'll include a link to figuring out if I accept, your insurance company that you have. Let me know what, questions you guys have in the comments. Is there anything I can clarify about this video? What topics would you like me to cover in the future? If you like this video, please give me a like, share it with someone that you think would also enjoy it. I'll be releasing a new video every week, so be sure to also subscribe so you don't miss them when they're released. I hope you guys have a wonderful week, and take care.